Hi folks, we're going to take a look at this question from the worksheet. So it's a question of modeling using a sinusoidal function. So let's take a look at what they tell us. So there's the tides that have a lowest point of 3 meters below sea level, which occur at 10 p.m. Sunday night, and then their highest point of 8 meters at 8 a.m. the next morning. And they want us to create a model for height with respect to time starting at 12 a.m. Monday. Okay, and they say use the model to estimate the height of the tide at 12:21 Thursday. Okay, so one of the reasons why we come up with these models is so that we can make predictions for the future. All right, so let's look at the information that they give us. So they tell us that they reached our lowest point, so that means our minimum. Okay, now I guess the first thing we have to do is we have to decide what our variables are going to represent. So we want height versus time. I would say the best thing to use for time would be time in hours, okay? Because here, once I get to 12:21 p.m., I think I'd rather do that than work with days. So I'll say let t be time in hours, okay? And we'll use h for our output variable, and we'll make it height, and we'll make it with respect to sea level, since that's what the heights are given as. Excuse me. So height in meters above sea level. Okay, so since we're below sea level here, our minimum is going to be -3. Our maximum is 8 meters above sea level, so +8. And we need our period. Okay, so here the period, well, let's see. It's at its lowest point, so it's minimum at 10 p.m. and highest point or maximum at 8 a.m. the next morning. So that would represent half the period. Since you're going from the lowest point to the highest point, the full period would represent from lowest to highest back down to lowest. So that means that our period is actually 20 hours. Sorry again. All right, so we can start calculating a whole bunch of the parameters here, and I'm going to deal with the phase shift at the end. Let's deal with all the other stuff. So we've got our amplitude, which is going to be max minus min divided by 2. So that's 11 divided by 2 is 5.5. Then we've got our axis, which is going to be 8 plus -3 divided by 2. So 5 divided by 2 is 2.5. All right, and our k value is just going to be equal to 2 pi over the period, which in this case here we found was 20. So that's just going to be pi over 10. All right, so what do we have here? We've got 3 of our parameters. We're just going to have to figure out the d value, in other words, the phase shift. So what I'm going to do is I'm going to use a graph to help me figure out in which direction I have to go. All right, so let's draw this graph pretending that we don't have any phase shift, okay? So here, the first piece of information they give me is the minimum. So I'll start with drawing that. So let's say I draw it starting with the minimum, in other words, a negative cosine function. So my graph would look something like this, okay? But I need this, so if that's initially my starting point, I need my starting point to be 12 a.m. and at 12 a.m. the water is on the rise, because remember, it's going from its lowest point to its highest point as we move from 10 p.m. to 8 a.m. Okay, so I need at 12 a.m. for the water to already be on the rise. So I'm going to move my graph in this direction, so I end up with a graph that looks like this. Okay, and we see here that at my starting time, the water's already on its way up. Okay, had it been going down during that period, let's say I was starting at the maximum and 8 a.m. was the minimum, I would move it in the other direction so that the water was on its way down. Okay, so that means that I'm going to perform a translation to the left, and I just have to figure out how long. Well, here it's 2 hours because I need the minimum to occur at 10 p.m. In other words, before my starting point. Okay, so that's why it's 2 hours, 10 p.m. compared to 12 a.m. So now we have enough information. So our phase shift here is to the left. And so now we have enough information to write out our function. So h is going to be equal to So again, what I decided to use as my parent function was negative cosine. So I'll put that here. The parent is going to be y equals negative cosine. And I essentially use that because that was the starting information that they gave me. It was at a minimum. Okay, so negative, our a value 5.5, cosine of our k value is pi over 10. Okay, and then of course remember that this needs to be in factored form, at least when I initially write this out. So here I've got t plus 2. Since I'm going 2 to the left, it's going to be t plus 2. And then here plus the c value, which is 2.5. Okay, and I can leave it in this form. Of course, nothing stops me from distributing the pi over 10 once I've written it out. But in order to correctly identify my stretch by a factor of 1 over pi over 10 and moving 2 units to the left, I have to write that in factored form. All right, so now we have our model. Let's see if we can solve the second part that they're asking us, which is the height of the tide at 12:21 p.m. Thursday. All right, so we just have to figure out how much time has elapsed from 12 a.m. Monday to 12:21 Thursday. Okay, so here, if this is Monday 12 a.m., so Tuesday 12 a.m., Wednesday 12 a.m., Thursday 12 a.m., so that's 3 days, so 72 hours. Okay, then we're going to 12 p.m., so that's another 12 hours, and then 21 minutes. Be careful, that's not 0.21, it's 21/60th of an hour. Okay, 60 minutes an hour. So let's put that all together to get an approximation. Okay, so what do we have here? We have 72 plus 12 plus 21 over 60, and that gives me 84.35. Okay, so that means here, what I'm finding is h at 84.35. So let's just stick that in our calculator. So we have negative 5.5 times cos of pi over 10 times 84.35 plus 2, and then plus 2.5, and there you go, 4.76 meters. Sorry about that. All right, so in the end, what this tells us, so if we need to know the tide, say we need to maybe ride a boat in that vicinity or try to walk across a certain portion of the shore, I need to know whether 4.76 meters above sea level will be safe for whatever it is I'm trying to do. Okay, so just to recap, define your variables, calculate your find your characteristics, calculate your first 3 parameters, decide on what kind of phase shift you're going to need, parent function, write out your model, and then from there you can use it to make predictions for the future. Okay, that's it for this one.